Alright guys, we're talking about chapter 3, section 3, metals of the periodic table. Some questions to consider. What is a valence electron? Just to review that. Which are the most reactive metals of the periodic table? Which are the least reactive metals of the periodic table? Okay, so think of those questions as we go through these notes. Alright, here we have some images of some metals here in a casing and in the glass, and if you notice it's a liquid metal. Here's some sort of tape, and here's some wires. The question then brings up, what is a metal? And looking at these different pictures, we can get some clues that are probably new to you, some characteristics of metals that are new. Maybe you picked up along the way as you've been working on your project, if you've been doing a metal element. Okay, chemists classify an element as a metal, such as using physical properties, using such things as hardness, shininess, also known as luster, malleability, and ductility. Two new vocab terms that you should get to know. They'll come up again throughout this section on metals. So malleable is the ability for a metal to be pounded into flat sheets. Think of mallets, pounding things with a mallet like a hammer, and that's what allows us to get foil or thin tape-like metal tape. So it's the characteristic of malleability. Different metals have different malleability, but in general, metals have this ability to be thinned out. They're also able to be pulled apart or pulled into a long, thin wire, and that's called the characteristics of ductility, or being ductile. And that's what our image here is of. Some other characteristics: they're conductors of heat and electricity, such as this image on the bottom right here, the tower. And we know that metals, you don't want to be outside on this lightning day with a metal pole, because obviously it attracts electricity. And if you've ever been burned touching a metal can or a metal pan, we know that it also conducts heat. Okay, so we have those properties. A fifth property is the ability for it to attract other metals by being magnetized, or having magnetic property. So we have ductility, malleability, conductor of heat and electricity, and a magnetic property. So those 5 properties qualify it being a metal metal element. Now, along the metal's chemical properties, if you look at these two images here, we'll talk about. When we talk about chemical properties, it's how well and how fast it combines with other elements. Combining is reacting. When it reacts with another element, it means combining with another element. For example, sodium and potassium, they're both very reactive. That means they really want to be with other elements. And when they do, in that process, when they combine, they're very explosive in nature when exposed to air and water. And here they're sealed in an oil container to protect them from exploding and reacting. Here copper reacts with the oxygen, and it sort of rusts into the screen. Copper is normally that nice shiny brown hue. Here it reacts and it causes that green copper look after it's been sitting for a while. On the opposite end of this chemical property, gold is unreactive, so it doesn't like to combine with many elements. It stays shiny and for a long period of time, and gold is also rare despite not being reactive. The term corrosion, corrosion means that a metal is worn away due to some other reaction, due to some maybe water, acid, other elements that would, or compounds that would make the metal be worn away or eaten away. It looks like it's been chewed away. Okay, here's a model of an atom. In the atom is our nucleus with 6 protons, 6 neutrons. If it has 6 protons, it should have how many electrons? It should have 6. And if you notice, these larger models here, the ones on the ring, are your electrons. So there's 3 and 3. Now there's special electrons called valence electrons. They are the ones sitting on the outside ring. They come in shells. Remember the introduction to the atom notes about the model of the atom? They realize that there are layers of electrons. And so the valence electrons are the ones in the very outer shell, kind of like an onion. And so there are 4 valence electrons for this particular element. There are 2 other ones, and they just sit on the inside, and that's enough for us to know at this point. So 6 protons, 6 electrons, but 4 of them are on the outside. Okay, the metals of the periodic table. Going with group 1 or family 1. It's lithium to francium. Does not include hydrogen. Hydrogen is actually not a metal. And they're called the alkali metal group. They're the first family group. They're very reactive. And here they are, sitting in their first family. They're very reactive. That means they always want to be with other elements. They are social in that sense of the elements. They're never found in nature alone because they're always combining with other elements. And so they only exist in compounds. Sodium and potassium, many common uses. They make food taste better. Without them, you wouldn't be able to lift anything because they're found in our muscles. Lithium in that family is common. Lithium batteries you may have heard of. Okay, so this is the first family. Very reactive, very violent in their reactions, and very social in terms of elements. All right, their reactivity is because of the valence electrons they have. So this first family has one valence electron. If you remember that there's a pattern to it. Family 1, 1 electron. Okay, they want to lose that electron, so because of that losing of an electron makes them stable, kind of calms them down. They want to get rid of that valence electron. So right here, lithium has how many valence electrons? 1. Sodium has how many valence electrons? 1 is also. They all have 1. Now if you look at this number, this is the proton number, atomic number or proton number. It has 3 electrons, but it has 1 valence electron on the outside. Sodium has 11 protons, but 11 electrons. But how many on the outside? Just 1 valence electron. So these have 19 electrons, but only 1 of them are in the very outside shell. Alright, the next group is the alkaline earth metals. They're the second family, from beryllium to radium. They are fairly hard, bright white, good conductors of electricity, as metals are, and they're pretty reactive as well, so they also want to combine with a lot of other elements. These atoms have 2 valence electrons, so they're family 2, and they have 2 valence electrons. Hopefully you understand the pattern. There's some loops in the pattern that don't work, but in general, that's what happens. They also want to lose their electrons, valence electrons. That makes them stable. So here's that family. Okay, 2 valence electrons, 2 valence electrons, 2 valence electrons, all the way across. Now they have 4 electrons, but 2 of them are on the outside. This one has 12 electrons, but 2 of them are on the outside. That means the other 10 for magnesium are in the inside. All right, transition metals. They're in this big block here, from families 3 to 12. You would think family 3 or group 3, how many valence electrons? If you figure out the pattern, you would say 3, but actually this mixed group here, the transition, they're kind of awkward. They vary. So in the same family, one might have 2, one other one might have 3. So it does not work. Okay, so the pattern breaks down in the middle. Family 1 has 1, family 2 has 2, and this one, it's not. There's no pattern to it. Also, we ignore this pattern for this middle section. All right, they're a bridge between the high reactive metals on the left side and then to the less reactive metals on the right side. So the reactivity goes down as you go from left to right of the periodic table for the metals. Good, hard, shiny with the luster, good conductors of electricity. Same thing with them, and they're pretty stable. Stable compared, especially to the ones on the other metals on the left side. Their number of valence electrons differ. That's what we talked about here. Okay, there's no set pattern. Metals in the mixed group. Their families 13 to 16. They're in the mixed group because they have metals, nonmetals, and metalloids mixed in. Metalloids are elements that sit on the zigzag line, and they have properties of both metals and nonmetals. So they have luster, but they may lack malleability. So because of their behavior, they sit on the zigzag line between metals and nonmetals. So they're sort of like a hybrid. Some of the metals include aluminum, tin, and lead, and they are metals themselves. Alright, our last group of metals are the lanthanides and actinides. These are rare earth metals. They because of their scarcity, and they don't really exist on Earth in large quantities, they're called the rare earth elements. And they're very unfamiliar elements to us commonly. They're not used a lot in our everyday lives. So here in the bottom row in brighter blue or darker blue and lighter blue underneath it, lanthanides on top, actinides on bottom. They fit in period 6 and 7, but they squeeze right in here, but if they were to fit there, this periodic table will be twice as long. It just pushes everything out. So to save paper, they slip it underneath the bottom. Lanthanides are difficult to separate because of their similar properties, and most of the time they don't really exist on Earth. They're man-made. They're made in a lab. Thorium and urium exist in small quantities, but after uranium, everything else is made using a particle accelerator where they shoot protons with much speed, and then they create new elements. And how do you create new elements? You have to add protons to the previous element. So remember, the atomic number, the proton number, is what identifies it. So by changing the protons, we can create a whole new element. But the problem here, from this third bullet, you see, they don't last for very long. So it's actually pretty exciting that they create a new element, but it lasts for a split second. And they measure that in images that they take. They take some sort of photograph, and there's evidence of the extra proton. So that's a quick, basic understanding of new elements created, especially in the lanthanides and actinides. Okay, so that concludes what we have to talk about the metals of the periodic table. Next section, we're going to talk about the non-metals. We're going to talk more about this again on next class, especially trying to understand the pattern of the valence electrons in each family group. Okay, thanks.